This is going to cover geothermal energy. So geothermal energy is a process where we use natural radioactive decay in the center of the Earth's core, which gives off heat and drives our magma convection cycles. Remember, that's the rising of the hot magma, which then cools and sinks back down. This drives our tectonic plates, also drives geothermal energy. So there's two ways we can do this. You can use the naturally heated water reservoirs underground, can be pumped up and then used at the surface, or you can take surface water, pump that down, heat it up, and bring it back. So it's mainly used for heating and electricity, pretty much only in Iceland, because they are at a plate boundary, which makes geothermal energy very accessible. So water is pumped from aquifers into pipes for heat. The steam spins the turbines. Again, same process we've seen with natural gas, nuclear energy, and coal. You can use the ground pump heat to heat or cool air or water around it. Geothermal sounds like a really great idea. However, some environmental issues is groundwater depletion if you're not recycling the water source, and it also releases corrosive chemicals. So groundwater sources are naturally containing sulfur, so corrosive chemicals. This can be made airborne when we use geothermal energy. So you have to use scrubbers in your power plants to reduce the amount of sulfur that gets put into the atmosphere. Some advantages is it doesn't release particulate matter. There's no sulfur, there's no NOx, and there's no carbon monoxide. Fewer CO2 emissions, and it's potentially renewable depending on how you manage your groundwater sources. But I do want to mention some disadvantages is that it's very specific to where you are. That's why Iceland is the main country that uses geothermal energy, because even if you have access to it, the cost of drilling deep in the earth can be very high, sometimes so high it's not even worth bothering. So that summarizes geothermal energy.